Well, M is the midpoint of this line segment, P0, Q0. So it will be average of these points, right? So the vector M will be equal to 1/2 P0 plus Q0. This is the first thing. What else? It is that this, if we consider the vector P0 to Q0, right, it will be perpendicular to this line. So the second one is, we can say is that, let's call M P0, Q0. This vector is perpendicular to this line. Is perpendicular. Perpendicular to the bisector. So bisector is this line. Bisector. Okay, so you see that this, remember, we want to find the equation of this line, and to write the equation of this line, remember, in the plane, we can write it in two ways. We can have a normal equation or a vector equation. So in any case, this will be a normal vector for this line, perpendicular. Let's also discuss this direction vector. So any vector, so we are considering things in the plane. So any vector perpendicular to P0, Q0 will be parallel to this line. So it will be a direction vector in our terminology. So any vector U perpendicular to N is going to be a direction vector. For the bisector. Okay, now let's see this on example, how we find. Example. So question is, find the perpendicular bisector. Bisector of the line segment. Connecting P0, the point, let's say, -1, 2, and Q0, whose coordinates are 3 and 4. Okay, so as I said, we are in the plane. So this is P0, and the other Q0 will be Q0 will be 3, 4. So this is our line segment. And we want to find this perpendicular bisector. So it will pass through the midpoint. Okay, so let's find it. So first of all, so you see that this P0, Q0, so let's write this vector. So M, P0, Q0, which is Q0 minus P0, you know. So what is this vector? Q0 minus P0. 3 minus minus 1 is 4. 4 minus 2 is 2. Okay. So what is it? So this is perpendicular to the bisector. So this n vector is going to be like the following: minus 1, 2, and yeah. So for 2, this vector, for 2, let me draw something here. So 4 units to the right, 2 units up, right? So let me write it here. So 4 units to the right, 2 units up. So it will be something like that. And so this will be what? Perpendicular to the bisector. Yeah, however, well, you see that, well, this is not perpendicular to this one, right? Of course, because we are not saying that n is perpendicular to this line segment, but it is perpendicular to the bisector. So bisector will be something that cuts in the middle. Okay, now what else we know about this line, this bisector? So it passes through the midpoint. So this bisector passes through this midpoint. So let's find this midpoint. This midpoint is, as we know, P0 plus Q0. So let's compute. So average of these two. So 3 minus 1, 2, which is 1. 4 plus 2 is 6. 1, 3. All right. So this bisector passes through what point? M, which is this point. Point with coordinates 1, 0, 1, 3. Okay, so is this enough to write the equation? It should be. So let's write the normal equation of this line. Normal equation of the bisector. So you know it will be something like what? It will be like AX plus BY plus C equals 0. So it will be something like that of this type. And what will be A, B, and C? So A and B will be these components of the normal vector. So it will be like, so normal vector is 4x plus 2y plus C, which I don't know for the moment, equal to 0. But I know that this equation will be like that. Okay, so how I can find C? Well, to find this number C here, I use the other property that this line bisector passes through this point, 1, 3. Okay, so it must satisfy this equation. So let's see. 4 times 1 plus 2 times 3 plus C must be equal to 0. Why? Because of this. The point 1, 3 must satisfy this one. So from here we see that 4 plus 6, which is 10. So C equals minus 10. All right, so our equation will be then, the equation of this line, 4x plus 2y minus 10 equals 0. So this is a normal equation for this perpendicular bisector. Okay, now I may ask also to find parametric equations for this line. So let's also discuss how we find it. So same problem. Find so find part B, let's say, find parametric equations for the same equations for the bisector. This one. This for this bisector, we will find normal equation. So you see that we need a direction vector, right? So direction vector will be, you know, parallel to the line. So it will be perpendicular to n. N is what? This vector 4, 2. So let's find the direction vector. So n is, we know that 4, 2, perpendicular. This is normal vector, perpendicular to the bisector. Can we find now a vector which is parallel to this one? Yes, so it will be, so this is the line. Yeah, so this is the line. This is n. But I need u, n1, which is parallel to this one. So u will be a vector which is perpendicular to n. So all I need is to find a vector whose dot product with this one equals 0. What should it be? Very easy. For example, this one, right? Minus 2, 4. So if I take the dot product of this 2, it will be 0. So this will be parallel to bisector. So it will be a direction vector for this one. Okay. So let's write the equation. So I know that this passes through this point P. All right. So direction vector. So let's write the vector equation first. Vector equation will tell me this. Vector equation will tell me this point M. So bisector is here. Bisector is here. So this was P0, Q0 here. And this was the midpoint. So bisector is this one. Pardon, bisector is here. Yeah, bisector is here. Pardon, my picture is not as just like before. So I put P0 and Q0 at long places. So this is what I want to say is this is typical point P on the bisector. P0 and Q0 are here. So P0 is here, Q0 is here. And then we have this bisector, which is this line. So this is bisector. All right. So it passes through M, direction vector U, and I have this typical point P on it. So you know how to write the vector equation. So this is the vector equation. This is vector equation. The equation of the line which passes through M with direction vector, parallel vector U. It is like that. P is typical point, general point on this line here. This is P, and we usually call this, let's call the coordinates XY, all right? And then XY will be equal to M. We have found M. M is midpoint, 1, 3. plus t times u. Well, we have found u as minus 2, 4. And from here, I'm going to write parametric equation. So it will be like xy. And this passes through the points 1, 3. And then I'm going to have t here times minus 2 here. And then 4t here. T times 4. Yeah. So these are our parametric equations for this line, this bisector. Parametric equations for this bisector. Okay, so you see that we would do the same thing. Well, let's do now similar thing for another problem. So this time let's discuss, related to this one, something called a symmetric partner. So regarding this perpendicular bisector thing, all we need to keep in mind is that it will pass through the midpoint, and its direction vector will be perpendicular to this line segment PQ. So let's now discuss symmetric partner. We will first do it for symmetric partner of a point partner with respect to a line in the xy plane. Okay, so what is the problem in here? So it is the following. So let's say that we have a line. We have a line L. And we have a point P not on this line. And by symmetric partner of P with respect to Q, we mean the point here whose distance to the origin, this line is same. So whose this vertical distance. So we want to find Q such that the distance between P and Q are the same. So Q is called symmetric partner. Partner of P with respect to L. All right. So how to find P? So this is with respect to L, symmetric partner of P with respect to L. Okay, so how can I find this vector Q? Okay, to find Q. So what can we do? So first of all, we can try to do the following. So we can find this. We find this. We find the line which connects P and Q, which passes through, P and Q. All right. Then use it to find. Then use it to find Q. Well, it may sound strange, but it will be easy, as you see in this one. Okay, so let's see it on an example. This okay, so on an example, let's find the symmetric partner of the point P 1, 2 with respect to the line, L. So this line will be in the plane, and in the plane we have a normal equation of a line. So let's say it is this one. So let's see how we find. So I'm using the same picture. So this is L. P is here. And we want to find this symmetric partner. So symmetric partner will be here. So that this distance will be same as this one, as you know. And we have this angle, right angle for both. Okay, so you see that we will first consider to find this line, which passes through P and Q. So although I don't know for this line, I don't know Q, but well, I know P. So this I don't know. All right. Well, I know that this point P is on this line through P and its symmetric partner. And well, I cannot write an equation for this line because I know for the moment only one point. However, I also know another thing. So you see that this vector, this plane has a normal vector. So I know the equation of this line. So I can write a normal vector for this one. So I know that this n, let me say, 2 minus 3 is a normal vector for this L. So this is a, so note that this n, this normal vector, is parallel to the line through P and Q. Okay, so this will be a direction vector for this line L. So let's call this one, should I call it U? No. Okay, so let's write this parametric equations for this line. Can I call this one L1? So L1. So I'm calling this line the line L1 through P and Q. So L1, let me call it. What will be its parametric equations? So I'm writing parametric equations of this line. So I don't know Q, I know P. So I know that it passes through points 1, 2, then my parametric equations will look like 1, 2 plus, now my direction vector 2t minus 3t. Yeah. Okay, so you see, I got this equation for this L1. Okay. All right. So what? This point, this is the equation of this line, which passes through P and its symmetric partner Q. I don't know for the moment Q. Okay, now what can I do? Now I can use this one to find this intersection point. So let's call this point M again. M. So let's find M. So let M be midpoint of this line segment PQ. Okay, what is it? Which is this intersection point, this M. This point M is also same in the intersection of L and L1. All right, so let's find M then. To find M, how can I find the intersection of two lines? I'm going to put this one into this equation. So let's find it. Let's find M. This intersection point. I'm going to put the equations of L1. So I'm going to write, put x equals 1 plus 2t, y equals 2 minus 3t into the equation 2x minus 3y minus 9 equals 0, right? This is how I find the intersection. So let's put it. So 2 times 1 plus 2t minus 3 times y is 2 minus 3t minus 9. This is supposed to be equal to 0. Continue. So we will have 2 plus 4t minus 6 plus 9t minus 9 equals 0. So from here, you see that 4t plus 9t will be equal to, yeah, if I'm not mistaken, 4t plus 9t is 13t. And then we are going to have 2 minus 6 minus 4 minus 13. Yeah. 2 plus 4t. So 2 minus 6 minus 4 minus 9. Yeah. So I have found t equals 1 from this one. If I have not done anything wrong. Yeah. Okay, so intersection M. Intersection point will be what? So I'm going to put t equals 1. Then I'm going to have x equals 1 plus 2 times 1. Y will be 2 minus 3 times 1. So this is 3 minus 1. All right, so this is my intersection point. Also, at the same time, so you see, the picture here is like what? P, I have Q here, and then there is this midpoint, M, this distance being same as this one, and there is this line L. But I know M, but I don't know Q. So on the other hand, how is M related to Q? So we know that it is 1/2 times P plus Q. Okay, so Q will be 2M minus P. Okay, so let's find these components. So 2 times, what is M? Components of M, 3 minus 1 minus P, What was P? P was 1, 2, you know. Okay, so from here we get 2 times 3, 6, minus 1 is 5. 2 times minus 1, minus 2, minus 2, minus 4. Okay, so we have found what? The components of the vector Q is 5 minus 4. So we can see that the coordinates of the point Q is 5 minus 4. And this was 1, 2. All right. So this is the symmetric partner of P with respect to this line Q. And this is how we find it. So we use many things you see for this type of equation. Again, the idea is, once again, let me say, we are given this point and line. To find this one, so we first find this line passing through P and perpendicular to this line L. We can do it because we will know a direction vector. And then after finding this line, find its intersection, which will be the midpoint between P and its symmetric partner, and then find the symmetric partner. Okay, so this was the symmetric partner of a point with respect to this line. Let me draw your attention to some special case. So remark. So let's say that we have a point xy. Okay, so we also have these coordinate axes, right? Which are also lines, right? So let me draw your attention to symmetric partners of this one. So symmetric partner of this point P xy with respect to x-axis. So let's call this point Q. So what is Q? What are the coordinates of this Q? X and minus y, you know, right? Similarly, we can consider symmetric partner of P with respect to the y-axis. R, and it will be minus x, y. So this special case is useful to keep in mind. All right. So this is the symmetry with respect to coordinate axes. So we can, this symmetric partner, we can think of it like reflection. So if you reflect this point through this axis, you get this one. Similarly, other one. And also similarly in this one here. So if you reflect this point with respect to this line, so as if you consider there is a mirror in here, then the symmetric reflection will fall into this point. Okay, so this is symmetric partner of a point with respect to a line in the plane. Now we may consider similarly symmetric partner of a point with respect to a plane in space. So symmetric partner of a point with respect to a plane in space is done in the same way. Computed similarly. So here is the picture. So we have, let's say, we have a, let's say, plane like that, all right? And let's say that we have a point here, P. We want to find its symmetric partner with respect to this plane, Q. So this will be such that the distance will be the same. So distance to the plane will be the same for P and Q. It will be reflection. Yeah, reflection of P with respect to Q. We compute this similarly. I will show it on an example again. All right, example. So let's find the symmetric partner of the point origin, 0, 0, 0, origin. With respect to the plane, x plus y plus z equals 1. Solution. So let's see what kind of a picture we have. So x plus y plus z equals 1. Can I sketch this plane? Well, yeah. So this is the plane. So let's find the intercepts, right? So at what points this plane will intersect the coordinate axes? So it will intersect here. If I put x equals 0, y equals 0, then z will be 1. And similarly, if I put y0, z0, then x will be 1. So my plane will look like what? So in the first quadrant, it will be like such a triangle, and then it will go in all directions. Now, this is our plane. And our origin in here, so I want to find its reflection. Okay. So let's start. Again, I'm going to looking at this picture. So let me draw another picture here. So this is P. So P is here, I say. Q symmetric partner. Symmetric partner. Okay, so yeah, so let's find this line. So let the line. Yeah, this, I said O, but let's call it P, right? P. Yeah, I confuse it with 0, so let me call it P, origin. Okay, so I will do the same thing again. So I'm going to write the line through P and Q. So symmetric partner Q. We do not symmetric partner by Q. Okay. So can I write it this one? The line through P and Q? Yes. So you see that there is this normal vector n. What is the normal vector for this equation? 1, 1, 1, right? Normal vector for the plane is direction vector for this one. So I'm going to write this line through P and Q. P origin. Now direction vector is this n, u. So it will be what? 0 plus 1 times t, 0 plus 1 times t, 0 plus 1 times t. Yeah. So this is the equation of this line, which I called, yeah, this is what I called L1. Okay. the line through P and Q, L1, let's say. Okay, now again to find this intersection, so let's call this point M. Okay, so to find this M, then put L1 into the plane to find the intersection. So let's find the intersection. So I'm going to put x equals t, y equals t, z equals t. And this was supposed to be 1. So t equals 1 over 3. All right. Which means that then M, this intersection point, will occur when t is equal to 1. So if t is equal to 1 over 3, so you see that x is equal to t, y equals to t, z equals t. So x is equal to y, equal to z. They are all equal to 1 over 3. So M is 1 over 3, 1 over 3, 1 over 3. Yeah. What is M? M is the point where the line through P and Q intersects the plane. So you see, this is on the plane because it satisfies the equation by definition. So x plus y plus z equals 1. Really, that 1 over 3 plus 1 over 3 plus 1 over 3 is equal to 1. Okay. So I have found M, but I want Q, which is now easy because M, you see that M is the midpoint of P and Q. Okay, again, I'm looking for Q. Q will be 2 times M plus P. Okay, so 2 times 1 over 3, 1 over 3, 1 over 3, plus, what is P? Origin, 0, 0, 0. So Q will be 2 over 3, 2 over 3, 2 over 3, yeah. So this is the symmetric partner of the origin with respect to this plane, x plus y plus z equals 1. So let me try to show it now on this picture. So, well, unfortunately, this picture is not exactly like that. So this was the plane, and our origin is behind this plane, if we think of it. And then its symmetric partner will be on this side, right? So it was on, P was on this side, then symmetric partner will be on this side. Yeah. So, and it turned out to be equal to 2 over 3, 2 over 3, 2 over 3. So it will be, if this is 1, so, you know, 2 over 3 will be somewhere here. 2 over 3 will be somewhere here, somewhere here. So let me try to show. And yeah, it will be somewhere here, but not on the plane. It's on the other side. Okay. All right. So this is how we find a symmetric partner with respect to a plane. Nothing changes. We write the normal vector and observe that the normal vector of this plane will be direction vector for the line through P and its symmetric partner. Then we write the equation of this one, write the parametric equation, and then put it into the equation of the plane to find this intersection point. And the intersection point will be the midpoint. Then we find this midpoint very easily. This point to symmetric partner very easily. So that's all for today. So we stop here. Okay, if you have questions, I can answer here.
Hocam, can I ask something?
Yes.
Türkçe sorabilir miyim?
Sor.
Şey soracağım hocam, sınavda buralar da dahil mi? Nereden başlıyor?
Evet, bu da dahil.
En son burası var yani.
Evet, en son burası var.
Tamam. Bunun section'ı kaçtı hocam bu simetri
Bu
olması?
3.5 bu geride.
Ha 3.5'e devam ettik burada. Tamam.
Evet, evet.
Teşekkür
Ama
ederim.
zannedersem bu plane'e göre simetriden bahsetmiyor ama aynı şey olduğu için burada yaptık.
Tamam hocam. Teşekkürler.
Önceki konulardan var mı hocam?
Önceki konulardan yani zannetmiyorum olacağını.
Ya önceki konu dediğim şey bu cross product falan vardı ya.
Ha onlar tabii ki evet evet. Yani var dediğim onları kullanacaksınız tabii ki. Evet evet bitiyor buyurun.
Tamam hocam.
Tamam.
Teşekkürler.
Evet yani cross product o vektörler dahil.
Tamam hocam.
Zaten buradan ayıramayız onları. Bu line plane temel olarak konularımız onlar ama
Aynen. Burada
ama
da
zaten kullanıyoruz. Dolayısıyla
aynen.
ayırmak mümkün değil. Yani vektörlerin hepsi diye düşünebiliriz
Hı hı.
sınava.
Tamam hocam.
Evet, başka sorumuz var mı? Tamam o zaman burada şey edebiliriz, kapatabiliriz. Görüşmek üzere.
Görüşürüz.
Görüşürüz hocam.
İyi günler.
İyi günler hocam.
Günler.